Farmer wishes to build a fence around a rectangular pasture. Apparently, mathematicians spend a lot of time thinking about farming, because there sure are a lot of fence and pasture questions. Okay, so you could make an astoundingly long, skinny enclosure that looked something like this, which would have hardly any area to it. Or you could make a really tall enclosure that looked like this, and again, it would have hardly any area. And somewhere in the middle, there's an optimal enclosure that has maximum area, and that is what we must find. So let's get this thing labeled and start writing lots of equations about it. Here's its length, and here it is again. Sorry, that's supposed to be a loopy L. And that's a W, and that's W on that side. And this partition down the middle is also W. More about that in a minute. So for the area that this thing covers, the area is just length times width because this is a rectangular shape. It doesn't matter that you've partitioned it down the middle. That doesn't really affect the total area. But the other constraint is the perimeter, like the length of all this fencing that you're laying down is going to be L plus another L down here, so 2L. And if this were a plain old rectangle, we'd be writing 2W here, but in this case, it's 1, 2, 3 W's. So more fence than a rectangle would require. And they say we have 600 meters of material to work with, so all that perimeter adds up to no more than 600. And we have to maximize the area, which means, and you've probably seen this routine before, we want to take this derivative, but it has more than one variable, so we must replace one of the variables, and so this equation to the rescue. We need to solve this for either L or for W, and I'm afraid we're going to get a fraction no matter which way we do it. I'm going to isolate L for no particular reason, just because it's the first thing I saw. So 2L would be negative 3W plus 600. Divide the whole works by 2, and you get that the length is minus 3 over 2W plus 300. I'm debating writing 1.5 here instead. I'll stay with the fraction just for now. I might change my mind about that in a second, but my point is you can use the fraction or the decimal form, whichever you find more tidy and comfortable. So now that we have that, here's our area formula. Any place that we have L, we can write this instead. So in place of L, we have minus 3 over 2W plus 300 times another W. Multiply that out, and you get minus 3 over 2W squared plus 300W. Pause for breath. Okay, up to here? This is length times width. This is the total area we're going to cover. We want to maximize this. We think that this area is going to increase, flatten out, and then decrease, and we want to know where the flattening out part is. That's our optimal value. And that happens when the derivative is 0. So one derivative coming up. 2 times minus 3 over 2, W to the drop the power by 1, plus 1 times 300, W to the 0. All that must equal 0. We solve that, which takes about a second and a half, and we get that our optimal width is 100. And the units are meters, I think, yeah. Okay, so our width is 100 meters. What about the length? Well, as usual, we've got this thing which is all set up to find a length. It's saying just give me a width and I'll take care of that for you. Our length is minus 3 over 2 times 100 plus 300, which is minus 150 plus 300, which is positive 150. Good that it's positive. It would be panic time if you had a rectangle with negative measurements, so this is what we want to see. Now, I found these, and that's nice. We know that our enclosure should be 100 by 150, but that's not what they asked for. They asked for the total area that can be fenced, and so the area will be 100 times 150. So the number they actually want is 15,000 square meters, and it turns out they don't care what the dimensions are, just what will those dimensions get us. But do check the question, please, whenever this comes up. We can ask for either one. We can say what dimensions will give the maximum area. We could ask what the maximum area is, or in some cases, even both.